The proof of derivative of inverse sine x, or sometimes we call arc sine x. So the graph of the arc sine x, or the inverse function of sine, v is with the red one. This is the graph, and the arc cosine x, or the inverse function of the cosine x, is with the blue one. But now let's go and prove the derivative of inverse sine of x. Let's see what it is. So it's here, and let's write a proof. We already know the function we can write with this way. Let's say y is equal to the inverse of sine x. The inverse sine x we can write this way. Sine with the exponent minus 1 x. And now we want to find the derivative. The derivative denotation we usually find in the differential form, dy over dx. And this is equal with the other denotation, that is y in a prime, so it means a derivative. So now what we want here, this we are going with the sine both sides. Let me go here, sine y is equal with the sine of inverse of sine of x. So we have this way here now. But we know, for example, if we have the function, the product of the inverse function and the function f is going to be just the argument x. So this is going to be equal with the x, and on the left side is going to be equal sine y. So this is a very important equation, because we are going to need in the other steps. So let me write here with a different color. So I'm highlighting with this blue color, with a red color. So when I'm looking for it, I will have a very easy to find. I can find easy, so it's not going to be hard to find it. And now this derivative here, let's take this derivative of this equation. If I'm taking derivative of this equation, is going to be the derivative of sine y is going to be equal to the cosine y time is derivative y, which is equal, if I'm taking a derivative with respect to x, the derivative of x is just 1. And now everything here I'm dividing by the cosine y. If I'm dividing everything by cosine y, then we are going to get as follows. So the y, derivative of y is going to be equal with 1 divided by cosine y. And now we are in this step here. Now in cosine y. But before I go any further, let me take here some trigonometric identity. And we already know the trigonometric identity cosine square x plus sine square x is equal to 1. We already know this identity, but it's important identity, because from this identity we can derive other important trigonometric identities. Is equal with 1. And now I'm taking a shortcut. If I'm putting the sine square in other side, it's going to change the sign, and cosine square x is going to be in relation with the sine square x, is going to be as follows, is 1 minus sine square x. 1 minus sine square x. Now we are in this step. But I needed to know, I wanted this to solve for the cosine. Because I need for the cosine, I'm taking the square root of the whole equation. And cosine x is going to be equal, cosine x is going to be equal, let me write this better, with the square root of 1 minus square x. 1 minus sine square x. So we are here in this identity, trigonometric identity. And now, instead of cosine y, I am plugging here 1 minus sine square y. But here, because it's with respect to the y, so just let me change the color. And instead of y prime, I'm changing this dy dx. It looks a little bit more fancy, but it doesn't make any bigger difference. Just it's a look a little bit differently. It looks maybe more beautiful. Dx is equal with a 1 over, instead of the cosine y, I am writing its trigonometric identity, which is equal with 1 minus a cosine square y. So we are here, cosine square y. And now, I'm sorry, not cosine square y, but sine square y. Because instead of cosine y, I'm writing 1 over sine square y. Okay, sorry for this mistake. And now, let me write everything here. Dy dx is equal, let me write here 1 over square root of this 1 minus, I'm going to write 1 minus, but instead of the sine square y, I'm looking at this important equation that I mentioned a little bit early. Sine y is equal with x, but sine square y is equal with x squared. So this one I can write with x squared. So, and now this is the desired result. So we already proved it. The derivative of the inverse function of sine is going to be equal, if we take its derivative, is going to be equal with 1 over square root of 1 minus x